Well, hello everyone. Thank you for being us. We are very excited to be here. Today, we are going to talk about important topic, cross-tenant vulnerabilities, and also tenant isolation, the importance of tenant isolation, how severe is cross-tenant vulnerabilities, and what we as an industry can improve, learn, and better protect our data, our customers' data, and so on. So by the end of this session, we will have very good understanding of what is tenant isolation, what is the pitfalls in implementing tenant isolation, what are the vulnerabilities that could actually risk our tenants' data, and how we can better protect our systems. So just about us, I'm Shir, the head of research at Wiz. With me on stage is Sagi.
Hi, everyone.
Sagi is a security researcher in our team. And we are part of the Wiz research team. We dedicate our work to find and uncover new risks and new vulnerabilities that could affect cloud customers, cloud organizations. And in the past 2 years, we developed quite a skill in tenant isolation and cross-tenant vulnerabilities. So this is a few of the research we published in the previous 2 years. We found severe vulnerabilities in major cloud providers, which allowed us to potentially access the data of other tenants in the service. We found issues in Azure, in Oracle Cloud, Enterprise DB, IBM Cloud, and Alibaba Cloud. And those issues are one of the cross-tenant vulnerabilities is one of the most severe type of vulnerabilities, as it might allow an attacker to access the data of thousands of service customers, which has very impact consequences. All the vulnerabilities you see here were reported and already fixed by the vendors. And it's not just us. In the past 2 years, we see a lot of research from the community, also about cross-tenant vulnerabilities in Azure, AWS, and many other services. And we came here today to try to bring awareness of those issues, as they are very severe. And we believe there is a gap in the industry where we talk about tenant isolation when we implement tenant isolation. So that would be the first topic. And finally, we will talk about how we can address those issues and better protect our managed services. This talk will be very beneficial for every service builder, every managed service company, if it's SaaS or PaaS companies. The agenda will start by covering what is multi-tenancy and what is cross-tenant vulnerabilities. Then we will talk about how tenant isolation is commonly implemented in the field. We will use multiple case studies based on our research. We will show the Alibaba Cloud vulnerability, the Microsoft Azure and IBM Cloud, and how we were able to access the data of other customers. And finally, we will talk about the Pitch framework. It's a framework we developed that will help us to assess and strengthen our tenant isolation in our own services. So now I would like to call Sagi to talk about multi-tenancy and tenant isolation.
Thank you, Shir. Okay, so before we can start talking about the cool stuff, which is cross-tenant vulnerabilities, we first have to understand a few concepts. So the first concept that we'll talk about is multi-tenancy. Now, I'm sure some of you are already familiar with this concept, but just to make sure we're all talking about the same thing, to put it simply, multi-tenancy is a software architecture in which a single instance of software is used to serve multiple tenants and multiple customers. And different customers are actually sharing some portion of the application. Now, whenever we as customer or as tenants use a multi-tenant system, we tend to take for granted the fact that even though this application is being shared among multiple customers, our data and configurations and allocated resources actually stays our own, and that no other customers and no other tenants can actually interfere with our data. Now, this concept is actually called tenant isolation. And together, multi-tenancy and tenant isolation are what actually drives modern software. So software as a service, platform as a service, infrastructure as a service, cloud service providers especially, they all heavily rely on multi-tenancy and tenant isolation, and they couldn't properly function without it. So now that we have a better understanding of what multi-tenancy is and what tenant isolation is, let's talk about cross-tenant vulnerabilities or vulnerabilities in tenant isolation. So cross-tenant vulnerabilities is essentially a security vulnerability class in which an attacker can access the data or resources of another tenant using the same multi-tenant system. And in practice, cross-tenant vulnerabilities actually impact any type of multi-tenant service. So cloud service providers are especially prone for this vulnerability class. Managed databases, web hosting, managed storage, all of these multi-tenant services are actually prone and can be impacted by cross-tenant vulnerabilities. And if we'll illustrate that, this is the same multi-tenant system that we had before, where there are several customers sharing the same system. And a cross-tenant vulnerability is when one customer, perhaps a malicious customer, can access the data of another tenant sharing the same multi-tenant app with them. Now, specifically, cross-tenant vulnerabilities has been quite trendy in the past 2 years, with more than 10 critical vulnerabilities being publicly disclosed that affected multiple cloud service providers in a variety of services. So databases were impacted. This is a vulnerability that we actually published in late 2021 in Azure Cosmos DB, where the impact of this vulnerability is that any attacker who managed to exploit it could have accessed the data of other Azure customers using Cosmos DB. As Shir previously mentioned, there were a lot of vulnerabilities that had the same impact that were published in the last couple of years. Okay, so the question is, what do multi-tenant service providers actually do in order to protect their customers' data? And there is no single answer for this. And in the last couple of years, we actually reviewed the environments of many services. And we've seen many approaches toward anti-isolation offered by different vendors. So let's review what we've seen being implemented in the wild. And for these all case studies, we're going to use database as a service as a case study, but the lessons here can be actually applied to any sort of multi-tenant service and not just database as a service. So the first approach that we see towards anti-isolation is what we'd call logical separation. And in the case of database as a service, this is when each customer has their own database. Each customer has their own database within a shared database instance. So multiple customers are sharing the same process of the database, the same database instance, but each customer receives their own dedicated set of credentials and dedicated scheme within that shared database. Now, the pros for this approach is that it is relatively cheap and simple to implement. However, in terms of security, this approach is essentially a single point of failure. All it takes for an attacker to access the data of other tenants using the same service would be a single database vulnerability in which they elevate their privilege to root, and suddenly they can access the data of other customers sharing the same instance with them. Now, for us as researchers, we also know that instances are very prone to misconfigurations, and in this case, an attacker wouldn't even have to exploit a zero-day vulnerability to elevate their privileges. They could just abuse a misconfiguration in order to access the data of other customers. And to illustrate this, we actually prepared a GIF. So in the case of logical separation, in order for an attacker to be able to access the data of other customers, what they have to do is first to compromise their own database, then elevate their privileges to root within the database, and then they will be able to access the data of other customers sharing the same database instance with them. Okay, so another approach that we see towards anti-isolation, a slightly better approach, is what we call container-based isolation. And in this approach, instead of multiple customers sharing the same database instance, this time each customer have their own database instance running inside their own container, and multiple customers may share the same virtual machine. Now, the pros for this approach is that it is still relatively cheap and simple to implement, and this time it requires twice the amount of vulnerabilities to actually break the anti-isolation. So you'd still need a database vulnerability the same way that you needed before, and this time, in order to access the data of other customers, you'll also need a container escape vulnerability. Once you escape the container, you can execute code on the virtual machine, and this is where you'll see containers of other customers and be able to access their data. While it's still a much better approach compared to the previous one, it still has its cons. So the cons are that, as some of you may know, containers are not considered to be a very strong security barrier because every once in a while there's being released a Linux kernel vulnerability, which can be weaponized in order to actually escape containers. And it's not a very good idea to actually build your whole tenant isolation model around that. And to illustrate this, we actually prepared a case study. This is the case of Alibaba Cloud AsparaDB. This is a research that we published about a week ago, which has fascinating technical details, by the way. And AsparaDB is a managed database service offered in Alibaba Cloud, and they're based in multi-tenancy around Kubernetes. And the impact of the vulnerability that we found there is, once again, anyone who exploited this vulnerability could have accessed the data of Alibaba Cloud customers, which is like very, very severe. And what happened there is that we, as researchers, managed to find a vulnerability within our own PostgreSQL instance, which let us elevate our privileges to root within the database instance and execute arbitrary code. And once we executed arbitrary code, we found out that we are running inside a container, and we found a separate vulnerability, a container escape vulnerability, which let us execute code on our node. And once we executed code on our node machine, this is where we found the containers that hosting the databases of other customers and could have accessed their data if we wanted to, which we didn't. So the third approach that we see towards tenant isolation, and this is actually the approach that we see most commonly being implemented in the wild, this is what most vendors tend to do, is what we call VM-based isolation. Now, in this approach, each customer has their own database instance running inside their own dedicated virtual machine. So what customers are now sharing is the physical compute and not virtual machine like the previous approach, or not like the database instances in the previous approaches. And the pros for this approach is that this time it requires 2 to 3 vulnerabilities in order to actually break tenant isolation. So you'd still need a database vulnerability in order to be able to execute arbitrary code. Perhaps you'll need to escape a container, but the key differentiator in this approach is that this time you'll have to find a virtual machine escape vulnerability. And VM escape vulnerabilities are much harder to pull off compared to container escape vulnerabilities. However, since now every customer have their own dedicated virtual machine, things start to get quite expensive. And besides expensive, things also start to get quite difficult to maintain. And we actually had a conversation with a Google engineer about a week ago on this topic, where he mentioned that from his perspective as an engineer, the stronger the isolation a service has, the harder it becomes for him to actually debug the service and solve problems within the service. The same way it becomes harder for attackers to actually access the data of other customers using the service. But during the last 2 years of our research, we did find vulnerabilities, like cross-tenant vulnerabilities in services that were based on top of a VM-based isolation. And in none of our research, we actually pulled off a virtual machine escape. So how did we do that? Now I'd like to reinvite Shir to stage to talk about alternative attack vectors for breaking tenant isolation.
Thanks, Sagi. So as Sagi mentioned, the virtual-based isolation, or VM-based isolation, is very good. It's what we see at most most commonly, we see it mostly in cloud providers, service, and other managed service providers, and it's actually the state of the art. But enforcing tenant isolation is not just isolating compute, because managed services are not just compute. There is other resources and other assets within the managed service environment. We see orchestrators like Kubernetes or Service Fabric. We see internal APIs, shared network. Usually managed services runs in a shared network environment, and tenants could have the possibility to communicate with each other over the network. We also we have storage and identities, and all those aspects need to be considered when we perform tenant isolation. So now I would like to show a case study where the compute isolation, or we can call it the resource separation between tenants, was pretty good. But the service allowed inter-tenant connectivity, which means that the network was not segmented, and it allowed one tenant to communicate with other tenants over the network. So this is the second case study. It's a cross-tenant vulnerability we found in Azure, in the Azure PostgreSQL Flexible Server. It's a managed database service. And the impact of the vulnerability we discovered is that it would allow a potential attacker to gain full read access to the databases of other Azure customers. The vulnerability we discovered was that once we gain access to our own database, we were able to communicate with other databases over the network and search for other vulnerabilities. The network access, because of the network access which allowed us to communicate with other tenants, we actually opened an attack vector, or an attack surface. So we happened to find a second vulnerability, which allowed us to forge SSL certificates and bypass the authentication to the other databases of other Azure customers. So what happened there, we gain access to our own database. Then we use the second vulnerability in order to gain full read access on other tenants within the same environment, potentially pulling their data and gain read access to the data. Now, we report this issue to Microsoft. Microsoft fixed it very fast. What Microsoft did in order to fix this issue was to just eliminate the shared network. Apparently, there was no need for the shared network. It didn't serve any purpose in the service. It was not there for a reason. It was just an implementation mistake. And once Microsoft restricted the network access between tenants, they not just fixed the vulnerability we discovered, they eliminated the entire attack surface, because now it's impossible for attackers to find or exploit other network-based vulnerabilities. So here we see a case where the design of the service was pretty good. The resource separation was also designed and architectured very well, but the implementation was not good enough. Now, I would like to go for the third case study, which is much more interesting. Here we saw a vulnerability that the architecture of the service was very good. The resource separation was also pretty well designed, but yet using issues we discovered in the orchestrator, in the service internal APIs, in secrets that were left in the instance, and misconfigured identities, we were able to pull off a cross-tenant vulnerability. So this case was in IBM Managed Databases. It's a managed database service offered by IBM. It's based on PostgreSQL. It's a PostgreSQL as a service. It's based on Kubernetes. And the impact of the vulnerability we discovered was the ability to infiltrate into an internal CI/CD server of IBM and potentially override production-ready artifacts, eventually allowing us to perform a supply chain attack on IBM internal infrastructure and IBM customers. So we started investigating this, we started this research more than a year ago, and we discovered that the managed database instance were running inside a Kubernetes namespace with no network access to other customers' data, to other tenants, and it was very good isolation architecture. Actually, when we tried to escape the node and to break the isolation, IBM caught us, as they monitored our activity, and they sent us an email, like, hey guys, what are you doing? So after explaining what we do, they allowed us to continue the research and to check if their service is indeed isolated enough. So continuing the research, we discovered that our node, the database node, had API network connectivity with the Kubernetes API. Now, this is pretty common, because in Kubernetes environments, sometimes pods have access to the Kubernetes API. And also, we discovered that we have service account credentials within our own pod, which means that we can authenticate to the Kubernetes API and perform some Kubernetes operations. And the first issue we discovered there was the ability to fetch the container registry credentials. Now, this is also a very common case, not just for managed services, for every containerized environment. Every containerized environment must have credentials to a container registry in order to pull images. In that case, the credentials for the container registry was first accessible to our own node, which we shouldn't have that access. But second, it allowed us to read the images, not just of the database, of this specific database, but also to read images of other databases. Now, as you can imagine, container registries contain a lot of data, a lot of artifacts, source code configurations, and at that point, we could actually gain visibility into other services of IBM, and also, we could search for secrets. Because if you have a very big repository, there is a good chance that some developer or DevOps probably forgot a secret there. So we scanned the container registry for secrets, and surprisingly we discovered the internal CI/CD server credentials, which had read and write permissions to internal CI/CD server of IBM services. So that could potentially allow us to override the production artifact and perform a supply chain attack. Now, when we reported all the issues to IBM, so now I would like to overview the issues and also to talk about how they were fixed. The first issue was the overprivileged Kubernetes service account. We had a Kubernetes service account in our own database, which allowed us to fetch the registry credentials. And that was the beginning of the chain. The second part of the chain was that these credentials allow us to fetch images of other services and potentially allowing us to search for secrets or other sensitive information related to other services or other resources in IBM infrastructure. The third part of the chain was that there was a forgotten secret within the container registry, which allowed us to access the internal CI/CD server. And the fourth issue was that we had write permissions, so that we can actually override production artifacts. Now, this is the toxic combination we discovered. We have 4 steps that we added, and this is eventually the kill chain, because without one of them, it will not be able to pull off this attack. So even if just one of them were fixed, we will actually be stopped much earlier in the operation, in the research. So IBM, to fix those issues, they first remove the container, the service account, the Kubernetes service account from the container, because apparently it was there by mistake. It wasn't needed. And the overly permissive container registry credentials, which allowed us to pull images of other services, they were scoped, because there was no need for them to have these privileges. And for the sensitive secrets that we discovered in the container registry, it was also removed because it wasn't needed there. And the fourth, the over-permissive credentials we discovered that allowed us to override the internal CI/CD server artifacts, it was scoped, because originally it was meant to use only to pull libraries from the artifact, from the repository, and not to have the ability to override. And here we see a classic case where the isolation issues was not in the design, was not in the architecture, it was hygiene issues. And hygiene issues and implementation issues are very unique cases where we don't see it much in a threat model, in a tenant isolation threat modeling processes. So the both cases were featured let's say, the services were designed with isolation in mind. They had an isolation architecture. They had a thought about separating resources from each customer. But the root cause of the vulnerabilities were not related to the resource separation. It was hygiene and implementation, like unrestricted network access or overprivileged access to internal APIs or to the control plane, overprivileged identities or sensitive secrets that were left in the environment. And almost all the cases we recently saw, not just by our research, but also research by other researchers from the community, almost none of them are related to compute isolation or mis-separating resources of customers. And most are based on hygiene issues and implementation issues, which are rarely covered in the threat modeling when we do tenant isolation. So here we believe we have a gap to catch as an industry. We need to create more awareness about tenant isolation, how important it is for software as a service, platform as a service, cloud service providers to isolate the resources to ensure that one tenant cannot access the data of another. We see that also with cloud providers, they have a lot of experience with tenant isolation. Actually, the cloud was built upon resource separation. We all share the same resources, the same physical compute, the same network. But SaaS and PaaS providers usually lack this experience. They lack the knowledge. When we talk with SaaS providers, we don't have a common language to talk with them. And this is where we must apply those key, like the tenant isolation practical methods in order to improve the security of our data. So now, I would like to call Sagi to talk about how we can assess and strengthen our own managed services. Thanks.
Thank you, Shir. Okay, so now that we all understand that cross-tenant vulnerabilities are a real threat and they can actually be pulled off in practice, let's talk about what we can do about them. So in the last couple of years, we reported many cross-tenant issues to many different vendors, and we started noticing similarities between vendors and common pitfalls that vendors tend to fall to, and different approaches that vendors have towards tenant isolation. And besides that, we also started noticing some recurring problems. So we started noticing that we don't have a common language with the vendor, that there is no standard for transparency regarding these issues, and that is a very minimal knowledge sharing regarding cross-tenant vulnerabilities as a whole. So our attempt to solve all of that is actually to introduce a community-driven framework, which we named Peach. Peach is a step-by-step framework for modeling and improving SaaS and PaaS security and tenant isolation. And we didn't develop it alone. It's a community project. And we had the chance to work with great people from Google, AWS, IBM, Cisco, Netflix, and probably other companies that I forgot. Yes, if tenant isolation is something that you care about and you are in the relevant role in your company, you should definitely check this one out. Now, Peach stands for Privilege, Encryption, Authentication, Connectivity, and Hygiene. And it is a circular process in which you first want to assess and then strengthen the tenant isolation of your service. The first step would be to map the existing interfaces within your application or your service. Then you want to assess their complexity, determine the current isolation level, consider the business context, so whether or not this component is actually worth protecting, and then modify the design accordingly, ideally by introducing more security barriers. So the first step would be to identify complex interfaces, and the question is, what makes an interface complex? Now, at this point, you really have to think about the components that you have in your application and ask yourself, can users execute arbitrary code here? If the answer is yes, this interface is definitely complex, there's no question about it. But even if users cannot execute arbitrary code, you have to ask yourself, okay, so what can they do? Perhaps they cannot execute arbitrary code, but they can invoke arbitrary HTTP requests. They can load files, they can load libraries. So you really have to understand what your application is doing. And some example for complex interfaces would be database services, as we've seen in this entire session. Content management systems, which seems benign, but in practice, most content management systems can be actually manipulated into executing arbitrary code. The serialization or the general handling of complex user input is quite prone to vulnerabilities. And also migration systems had a couple of cross-tenant vulnerabilities in the last couple of years, probably due to their support in third-party plugins. Now, after we've identified the complex interfaces that we have in our service, we'd like to introduce multiple security barriers. And the goal here is to actually prevent a situation where one vulnerability is enough to break the tenant isolation architecture of our service and allow attackers to access the data of other customers. Ideally, we'd like to introduce multiple security barriers that are independent from one another. So when an attacker breaks one security barrier, they still have to face another one. And when designing security barriers, you ideally want to follow the concept of least privilege, meaning that you'd want to restrict the component capabilities as much as possible and ensure that your application is doing whatever it's supposed to do and nothing else. And the final step would be to ask yourself, should this really be shared, or can we actually dedicate one of these to each customer? And we'll use database as a service once again as an example, but if you ask yourself the question, should the application, in this case a database, be shared, or can we actually dedicate one to each of our customers, suddenly you go from row-level security to container-based isolation, which is a much higher degree of tenant isolation. Same goes for the kernel in the shared virtual machine. If you decide that you do not benefit anything from multiple customers sharing the same kernel of the virtual machine, suddenly you go from container-based isolation, which is a certain degree of tenant isolation, to VM-based isolation, which is a much higher degree of tenant isolation, once again. And same goes for the network. If you decide that you do not benefit anything from multiple customers sharing the same network, and you can actually dedicate each of your customers with their own network, suddenly you reduce a lot of attack surface and essentially eliminate a big portion of the vulnerabilities that we found in the last couple of years. Same goes for credentials and so on and so forth. So I think that at this point, we can all agree that we could benefit a bit more from transparency in cross-tenant vulnerabilities. And the issue here is that unlike most traditional software vulnerabilities, specifically cross-tenant vulnerabilities and cloud security issues as a whole do not explicitly require a CVE, and therefore vendors tend to not release a CVE for them. And this makes the job of tracking these issues and being aware of these issues quite hard for security professionals. So to solve this issue, or our attempt to solve this issue, was to introduce CloudVulnDB. This is once again a community project which we happen to take part into. CloudVulnDB is a database, online database, that's attempt to index each and every cloud security issue, and whether or not it did receive an official identifier from the vendor. And with each issue that we index on CloudVulnDB, we actually try to link to the technical details of the issue. So security professionals like you would be able to read the technical information, understand the root cause of the problem, and implement the lesson learned on your application as well. And with that being said, I'd like now to invite Shir to talk about the takeaways from this session.
Okay, so the key takeaway is that tenant isolation is important, and we should first understand the risks in our own environments. If we are a service builder, service providers, we should definitely start by mapping the interfaces we have in our own environment, identify the complexity, and determine the isolation. Like, what is my current isolation level? Usually we can do that also with our red teams. Like if you have a service you suspect or you want to know what is the current isolation level, ask or hire a red team or ask a red team to do evaluation of the service, provide them with access to the service, and ask them to try to access the data of other customers, or to prove it's possible. Also, we need to consider the business context, because tenant isolation is quite expensive. And we would like to perform it only where we have critical data, where it's our customers' data, our partners' data, where it's important. For internal development systems, we don't must enforce isolation. The second part is to improve the isolation. We do that by reducing the complexity of the service, increasing the duplication, so more customers will use dedicated instances and have improved the separation. And this is the part where we're actually modifying the architecture of the service and better protect it against cross-tenant vulnerabilities. And the last, and one of the most important parts, is we must maintain the isolation. So we must regularly monitor the environments for hygiene issues, for secrets that were left from the CI/CD or from the build process. We need to check that none of these issues breaks our isolation, because once we put a lot of effort into building an isolated architecture, the tiniest secret, like a credentials for a GitHub repository forgotten in one of the images metadata, could break it all. And also, we need to reassess the environments every time there is a significant change. So if our development team is improving the service, modifying it dramatically, we need to stop it for a moment and reassess that it does not impact the current isolation model. So this is the key takeaways. This is what we created with the pitch framework. I think it's a good time to go for questions. Thank you very much. Yes, please.
Hi, I have a question. During all this testing, were you caught by maybe the cloud provider for breaching their system? Is there any audit trail left behind?
Is it any audit trail for customers?
Yes.
So it really depends on the vulnerability. Some vulnerabilities that are more like cloud native vulnerabilities could sometimes have like a cloud trail or you can have some log. Most of the vulnerabilities, it's the cloud service responsibility, and usually customers will need to ask the cloud provider. There is no way to know if it's
So were the cloud service provider caught you in action?
Yeah, multiple times. We had one with Google, one with IBM, and also with Alibaba Cloud. They apparently, we discovered it after the report, we discovered that they monitor their activity.
Hey, thank you.
Thank you.
Hi, I have another question.
Yes.
Great presentation.
Thank
Complex topic, explained very, very nicely. My question is, in the grand scheme of things, of all the vulnerabilities, how important it is?
Like the cross-tenant vulnerabilities?
Yes. What do you think? I mean, like, there are so many other vulnerabilities to take care of.
Yes.
So how much time should one spend on?
Okay, so first of all, cross-tenant vulnerabilities are mostly important for managed service providers. Service providers who usually host the data of multiple tenants on the same infrastructure. I think it's very important. Usually, the nice thing about tenant isolation, it's actually make you more resilient to vulnerabilities. Because if you implement a good architecture and isolating the tenant data, you can actually be in a position where a vulnerability, if someone exploits a vulnerability on infrastructure, they get nothing. I mean, they are just like in kind of a sandbox or a jail. So I really believe that sandboxing and tenant isolation is actually the way to get rid of all the noise of other vulnerabilities.
So there are so many cloud service providers today.
Yes.
You're saying that, I would assume that Azure is going to take care of most of it.
Oh yeah, it's definitely Azure responsibility. Yes.
So then what about those cloud service providers that are out there? Do you see them playing a role in this? Do they need to do anything? Or?
So I mean, every service providers, as much as the service provider is big and have a lot of experience, they do much better tenant isolation work. Most cloud service providers do very good job on tenant isolation. The cases we show here, once we report those issues to the cloud service provider, they actually take the key findings and they assess their entire environment in order to better protect and better harden their infrastructure. And my concern is not about the big cloud service providers, it's about the small ones and the platform as a service and managed software as a service.
Okay, thank you.
Hello. A lot of these cloud providers have user agreements, like in your IBM instance, your case studies, where they ask you, what are you doing? What did you tell them to continue to test?
To continue the test. So it really depends on the cloud service provider. With IBM, for example, they were very professional. They knew our previous work, and they assumed that it will be very beneficial for them to assess the isolation. So it took us quite time, but eventually they really want us to do that.
It's in their favor. They get like free security testing.
Thanks for the presentation. Important issue. One question is, could the cloud service provider, after you discovered the vulnerabilities or the attack vector that helped, could they make a statement whether this attack path was used before?
So definitely we see those statements. We saw it when we work. Sometimes the cloud providers issue an advisory. Sometimes they don't.
Yeah.
If they issue one, they usually will have this statement that they validate. They went over their logs and checked if the vulnerability was exploited. So it really depends. I mean, some cloud providers have a lot of logs. Some have less. It really depends on the service. There is services that it's much easier to keep logs for a much bigger period of time.
Sure.
Some services you can only have a retention for like 1 week. So it really depends on the cloud service providers. With our research specifically, they gave us a statement that they reviewed the blog that we shared, and they gave us the statement to write that the vulnerability was not exploited. Most of the times they give us this statement.
Yeah. May I have one last question? Heard that, of course, focusing only on tenant isolation. What do you think about confidential computing? So how much worse is added by confidential computing in the view of that attack vector, of course?
Yes. So I think it's a very good question. Conventional computing it's like it feels like a very bright feature. Like we can actually use a dedicated like closed core in the CPU to handle this data. But if we look at it in a high level, VM-based isolation is good enough. Okay. So if confidential computing is just like an extra step beyond virtual-based isolation, and we see that most of the mistakes are not in the computer isolation. So I'm afraid that most teams will not know how to utilize this confidential computing hardware, and the mistakes will be hygiene issues, implementation issues.
Okay, thank you. Because I'm coming from debates where it's always like, oh, we need physical separation, you know. So this is the background I'm from, so and I will try to get as much arguments as possible to say, we're doing cloud, we don't need it, you know, we don't need it, and we have to focus on other things.
So usually it's very easy to find a way to bypass it because of small mistakes.
Yeah, exactly. Okay, thank you.
I just had a quick question about if you're a user of a cloud service, you're not necessarily a SaaS provider, what's the best way to protect yourself against a tenant isolation vulnerability?
Surveys. Like just ask your cloud provider, how do you protect my data? How do you separate the resources in the services I use? It's very tough questions. And then when you ask them those questions, they will go, they check. If they see that they actually do things not the right way, they also will fix it. I'm a big fan of sending surveys. If you're a big company, they must respond.
Hi, great topic, and thank you for presenting. So question for you, have you done any research on the SaaS layer? Because a lot of the vulnerabilities or research that you've done is at the kind of IaaS layer. I'm just curious, is that the same approach, or is there's a difference in terms of targeting the multi-tenancy within SaaS versus within the IaaS?
Yeah, so it's basically almost the same with SaaS, PaaS, and cloud service providers. You have an environment with multiple applications, and once an attacker executes code on the application of the SaaS provider or one of the applications, usually they can try to perform a lateral movement and access the data of other customers. And the process we show in the presentation, for example, the logical separation within a database. It's a very good case. We also use it in our own company, where it provides you very good separation between users' data within the same database. So it could be a very good protection against SQL injection, for example. Once one tenant found an SQL injection, they will not be able to access the data of other customer because it's in a different database within the same instance. So it's also applied to almost any attack. And also, as a SaaS provider, you utilize a lot of identities, shared storage, shared network, segment those, try to scope the identities for each user will have a specific privileges. Also with storage, a lot of storage devices provide identity mechanism. So also scope those, and it's do magic for any application that runs in a shared environment.
Thank you.
One question. If you start to build an architecture, would you agree that it's the right way to have it as simple as possible, even if tenant isolation is maybe not good enough, let's say. And then, of course, if you are in a container and so on later on, you can migrate, you can add virtual machines. So would you agree on that making the easy steps first, because there are so many other attack vectors, identity theft and so on, we have to deal with, that this is a solution and a possible way to improve tenant isolation later on?
You mean like when it really depends. When you start building the service, you're talking about like the first steps of building the service, like before doing the architecture, or like after doing the architecture.
You're building the service and you have you get an architecture, but I'm thinking about the complexity that you have to deal with if you go with VM virtual machines. So you have much more responsibility.
Yeah.
And to know the path, what would you think is the best path to get a good enough tenant isolation? Go the hard way because it's worth it, or just start with the easy way and then improve?
Yeah. So if you're just starting to build a service, so it's very important to have this to do this work during the design and building the architecture. So to think about how we can architecture the service, that data will not necessarily be located on the same assets or with other customers, and to think about potential isolations that you can implement maybe in the future. So to start with, it's much more convenient, I believe, to start with containers and to shift to VMs rather than to start with a shared database. And then when you discover you have an isolation issue, you're in a problem.
Okay.
So it's usually it really depends on startup companies. Usually want to run fast. They don't think security. Big companies that develop like cryptocurrencies companies, they think security from day one. They know they are protecting very high valuable asset. So it really depends on how much you want to invest in that security.
I'm from a government agency, so not a startup.
Yeah.
To pave the way, to get good things done, but in a fashion that you can really say, okay, I can trust that solution initially. So go into a container, and then later on you can have more separation, but not just logical.
And also there is very cool projects. For example, Google gVisor or AWS have a Firecracker, which are very easily built instead of containers, and they are utilizing the hypervisor in order to provide much better security for the container. Yeah. So if you are already running a container-based isolation model, you can enforce it, you can harden it very good just with some tools, and you don't have to replace to...
If you are at Google or AWS.
I know.
If you do it by yourself.
No. It's open source projects.
Sure.
The funny part is that Firecracker does not run on AWS because they don't support nested virtualization.
So I have to look at it. Thank you.
Any more questions?
Thank you, everyone.
Yeah, thank you very much.